Thanks, everyone. Day 3 of VMworld. It feels like day 20 here. I am Dwane Lessner, SC for Western Canada for Nutanix. Today we're talking about X-Men powers of the data center. We're going to talk about some of our new features, inline dedupe, how we do link clones, how we do some healing, and our new Prism UI. So our theme for VMworld was liberating the data center from tyranny. So we have 4 X-Men characters: Rouge, representing dedupe, Nightcrawler, showing how we do link clones, Wolverine, showing how we do healing, and finally Xavier, our new Prism UI. So Rouge, her superpower, absorbing data, sucking it in, and then using it against you. For our use case, it's our inline dedupe. First dedupe to expand both RAM, flash, and the hard drive tier. So this release for our 3.5 is all about application performance. Even though you're low flash tier, you might have a small flash tier now, you'll have the ability to grow that seamlessly all in software. The beauty of this, it allows you to avoid doing CBRC, content-based read cache from VMware. No longer do you, if you're a VMware view shop, you have to do that. So what's that going to do for you? It's going to save you a ton of time doing provisioning with link clones. Also, this feature is fully in software. We have no hardware crutch to rely on. As we span versions going from Sandy Bridge to Ivy, you can scale up right away. Nutanix will be there to have a seamless upgrade path so you can avoid the rip and replace. So from a perspective of our inline dedupe, we have something that we call single touch, multi-touch. So this is built for VDI. So it'll allow a couple of different new use cases. One, persistent. Before, I would never argue against for persistent desktops, but the thing that I'd like to point out, usually if you're doing a VDI, non-persistence is the way you want to go. Why? Because you can manage the user data. What this allows you to do is to use full clones. You can manage your physical desktops and your virtual desktops the same way. And what I mean is if you're a Microsoft shop and you're using SCCM, take that same tool from physical world and apply it to your virtual desktops. That way, wherever you are, physical, virtual, you can manage it the same way. We're also implementing a feature called fingerprint on write, dedupe on read. So as the data comes in, we're going to fingerprint it. We're going to do a SHA-1. We're going to stick that in our Cassandra database. So we have a distributed database that goes across our entire cluster. That fingerprint gets stored. When that data gets read, we're going to dedupe it, bring it into what we call our content cache, and it will be available. Since we're also doing this fingerprinting, at a later version, we'll have the ability to run an algorithm and actually show it what can be deduped on the hard drive tier in a very effective manner. You know, we're doing everything in software, and you can't break the law of physics, so you have to deal with CPU, so we're using that the most cost-effective way. We have a lockless architecture for VDI, meaning that random I/O is not going to be a bottleneck in our dedupe process. We can actually sense what's happening on the wire, and by default, it's 64K. You can set that. With all the features in Nutanix, we're kind of hitting the 80% mark where you want to be from set and forget. But if you have a special use case, you can switch that around. So fixed or variable. So we had a decision to make when we were doing our dedupe. Are we going to use fixed block or variable? We have settled on fixed for our implementation. Since we handle the way that the data goes down onto disk, we have selected fixed. So 64K, we'll break that 64K into 4K chunks and lay it down. We did some performance testing. If we were going to go variable, the issue was if the workload was fragmented, you wouldn't see the benefits. Since we control that, we decided to go with fixed. So RAM and flash, say you have RAM over here, and you have flash over here. What we're going to do is make a circle that covers half of that container for an example. And we can call that our silly putty. So wherever you want to set that, whether you want to start off with the defaults, which is about 2 gigs of RAM and 2 gigs of flash on each node, that'll be the dedupe content. But you can, if you want to stick a whole operating system in RAM, you have that ability to do so. I call it good touch, bad touch. So the good touch is single touch. So we reserve 20% of that space for single touch, meaning if you have an AV storm or stuff that's only getting hit once, it's going to go in the single touch. And so if an AV storm happens and you keep getting all these hits, you have the ability to wipe out all that work you've been deduping. So we reserve that for 20%. If a file gets read twice, it goes into the multi-touch. And so that available space, you'll be able to use it all, but if there's contention, we'll slowly shrink back the single touch pool and allow that multi-touch to exist. There's no gotchas with doing our dedupe. You can still do vMotioning across your entire cluster. It's lockless. You can reboot your host. Since we store the fingerprints, that data is quickly primed with no overhead. We mentioned how we were able to sense the workload for that 64K. We have a concept of a vDisk controller, and that's how we're doing that. That 64K is adjustable based on performance. So I already mentioned that the main use case is going to be for persistent desktops, or where maybe we have a series of models, 1000, 3000, 6000, with various degrees of flash. So now even on the 1000 series side that has a limited flash footprint, you'll be able to do desktops for that remote branch office, with the same level of performance you would get from the big guys. So this is our second feature, how we handle link clones. Traditionally speaking, you get one file, one storage controller, and that's just the way it works today. So with link clones, there's a replica that's formed where all the reads come off. So as desktops go on in a traditional footprint, that replica becomes a hotspot for your data. With Nutanix, that all goes away. So here, we have a replica sitting on one of our controller VMs. If we look at our architecture, each node in Nutanix has a controller VM, a storage controller. And that's one of the reasons that allows us to scale. It takes that local flash and the capacity drives, puts it into one giant cluster, and removes the need for a SAN. So traditionally speaking, if you had that replica, it's only going to be one storage controller taking that full load. We can actually sense it on the wire. If multiple people are reading that replica, we'll take a snapshot, mount it to each controller VM, and read it locally, preventing any hotspots and localizing the traffic. That's essentially what's going on here. If you have that one replica, all the controllers are being used. At the very minimum, Nutanix starts with 3 storage controllers. As you scale up to, say, 2,000 desktops, you have 80 storage controllers, and that number keeps going up. Performance is never bottlenecked at the network or at the flash tier. So healing and performance. How do we do that today? So we kind of mentioned the concept of a controller VM. The more controller VMs, the better. They all help participate in healing. So Nutanix doesn't use RAID. We use replication factor. By default, it's replication factor 2, meaning we're going to write locally, and for availability, we'll go up to the 10 gig switch and write somewhere in the cluster. As you add more nodes, we can intelligently place that data across the cluster. More blocks will ensure that we place that data off of a block, so then we get a concept of block awareness. The other benefit is all these controller VMs help to rebuild data. In a small cluster with 4 nodes, 1 terabyte drive takes about 1 hour. If we're talking on the stupid end, a 2,000 node cluster, a drive will take 15 seconds to rebuild. And so that's why we're able to scale to the nth degree without performance bottlenecks. We actually run a map reduce job on the back end called Curator. So for performance, we have about 100 IR operations that we allow. 75 are for performance-related tasks, but 25 are for maintenance. So those maintenance tasks get queued across the whole entire cluster. The job, a task list gets formed of all the duties that need to be done. It's broken up into small jobs, and then the data is rebuilt. And so kind of the neat concept, too, from a healing perspective is you can actually lose all of the drives in the cluster and continue on. And what I mean by that is you can lose a drive, we'll rebuild it. That's fine. Then you can lose the next drive, rebuild it. lose the next drive, and this can go on and can go on and go on. So mining, oil, gas, those type of verticals where you might be in remote locations where you don't have access, you don't have to really worry about kind of babysitting it. It'll heal itself. So one of the other things that Nutanix brought with our 3.5 release is Prism. Alluding this from the X-Men, Xavier, kind of the all-knowing. You know, lots of talk in the media too on the NSA side of the house. I think it's a very fitting, actually, as a name because, you know, it knows everything. You can get both hypervisors, storage, compute, VMs, all in one central screen. The other thing that it can do, it also has a REST API. So Nutanix won Best of VMware or Best of VMworld 2013 this year, and so this is probably one of the reasons why we would probably get that award, having a REST API. Even if you don't know anything about the REST API, which I'm not a stickler, I don't know a lot about it, but with this, I can go into the menu, expand this out. You can't see it here. If we had time for a demo, we could bring it up, but it kind of brings in all the fields. You click over here, it fills it up. With little or no knowledge, you can get this going. The other reason for Best of Cloud is also we're multi-hypervisor. ESXi, KVM, Hyper-V. It's whatever your business allows, you can get going. Also on the Prism UI is the concept of analysis. So you can set a range. You have multiple metrics, anything that's in vCenter, and all the storage stats actually come from our own hardware system. So you can go in at a fine level from a host, a VM, where you can take a whole knowledge approach and kind of get trending forecasts for your environment. Those are the high-level features from Nutanix, the 3.5 release. Thank you very much. Yeah.